Hello all, welcome to the video lecture. In this video, we'll be discussing about the predictive analytics. While talking about the predictive analytics, it uses the historical data to predict the future events. Typically, the historical data is used to build a mathematical model that captures the important trends of the data, and the predictive model is then used on current data to predict what will happen next or suggest actions to take for the optimal outcomes. And in short, we can say that predictive analytics tells us what is likely to happen in the futures. Now, if we see some basic workflow of the predictive analytics, let us just see a basic simple example like a power company, like a predictive model of the power companies, how they use or how they develop the predictive analytics model. Basically, the power companies rely on the accurate load forecasting to minimize the financial risks and optimize the operational efficiency and reliability. And the energy producers and grid operators and traders need the accurate forecasts of the energy load to make decisions for managing loads in the electric grid, and vast amounts of data are available, and using the predictive analytics, grid operators can turn this information into the actionable insights. We can see here the basics of workflow, like first you need to have access or explore the data, like we need to access and explore the data which may be in the file like CSV or database or sensors, and then we pre-process the data. Like the data may be so messy, we have to process these, or we have to filter, we have to clean the data by removing the outliers and combining the data sources, and then we may have to extract the features, and then we need to create a model or develop the predictive models, which includes some kind of machine learning algorithms, or we need to go for parameter optimization and for the model validation, and then finally we integrate the analytics with the systems. Let us see like the step-by-step workflow of predictive for the energy loads. Like typically the workflow for predictive analytics applications follows these basic steps. First, we have to import the data from varied sources such as web archives, databases, and spreadsheets. Like the data source includes energy load data in CSV file and national weather data showing the temperature and dew point. Similarly, next we have to clean the data by removing outliers and combining data sources, like identify data spikes, missing data, or anomalous points to remove from the data. Then aggregate different data sources together, in this case creating the single table including the energy load, temperature, and dew points. And next step is to develop an accurate predictive model based on the aggregated data using the statistics, curve fitting tools, or machine learning. Like the energy forecasting is a kind of complex process with many variables, so we might choose some kind of machine learning techniques which may include neural networks or some more complex machine learning techniques, and we build and train this predictive model, and we iterate through our training data, and we set to try different approaches. When the training is complete, now we can try the model against the new data to see how it will work and it perform. And finally, we integrate the model into the load forecasting system in the production environment. So developing predictive models, like the predictive model uses mathematical and computational methods to predict an event or outcome, and these models forecast an outcome at some future state or time based upon the changes to model inputs. Using an iterative process, the model is developed using the training data set and then test and validate it to determine its accuracy for making predictions. And we can try out different machine learning approaches to find the most effective model. So we'll go through the in order to develop the predictive models, we have to go through like different types of machine learning approaches or some curve fitting tools or some statistics. And being more specific, we'll be discussing about the machine learning techniques. Talking about the machine learning, it's an art of making the computer learn by itself by providing the enough data to learn to the machine. And it's a field of computer science that aims to teach computers how to learn and act without being explicitly programmed. And it involves the construction of algorithms that adapt their models to improve their ability to make the predictions. So basically, there are three types of machine learning. First one is the supervised learning and unsupervised learning, and third one is the reinforcement learning. While talking about the supervised learning, it is learning from the leveled examples or learning with the teacher. Here what we do is train the model by using the level data, and here the level data means data is tagged with the right answer. And we make the model to learn the pattern which we can make to predict the outcomes for the newer data. Like the example of the supervised learning is like learning from the leveled example, like learning with the teacher under the supervision of the teacher. And like we can say here, the data are leveled, and we already know the input and output. And some examples include like prediction and classification. And we have got the inputs, and we have the supervised learning. We give the training information with labels, which we call the target outputs, and on the basis of these two inputs and the labels we get the output, and we estimate the error. And uh, the error is estimated on the by taking difference between the target output and the actual output. And the supervised learning, it tries to minimize the error. It learns by minimizing the error of this target output and the actual output. Like let's see a simple example of the supervised learning. uh, for example, suppose we have an image of a cat or animal where we can tell it's a cat. Like we can say, when we see this image we can say it's a cat. However, the machine cannot recognize it just by feeding it to the computer. So what we do is we give computers lots of images, like lots of even thousands of images to make it learn from the images. And it will be able to learn, like basically how it learns is like it will be able to learn what a cat looks like by its different features. Like we can see here the uh, like such as its four legs and two eyes, two ears, and whiskers, and other more features. Like it learns from the different features. And then next time when we give the image, like when we give this image to the computer, and the computer can identify it's the image of cat. Like when we test, then the computer will identify and the process by which we make the machine learn about uh, learn about the data or from the past or past level data and use the learning to make the inference of the future data is known as the supervised learning. So the supervised learning can be further divided into two different categories. The first one is the regression and another one is the classification. Basically, these types of supervised learning is categorized on the basis of type of the variable it is predicting, and in regression the type of variable which we are going to predict or which the data which are going to be predicted is numeric, or it has a certain range of values. For example, some price of data, price of house, or the weather that's going to be forecasted. And as we discussed in our previous example about the load forecasting, and here the data going to be predicted has certain range, and it has a kind of data that is numeric. And in classification, the type of variable which we are going to predict is categorical or discrete, like whether the given image is cat or not, or the image being diagnosed is cancer or non-cancer. And on the basis of the data which is going to be predicted, that will define the type of supervised learning. Well, the unsupervised method of learning is a kind of method by which we make the machine learn the hidden patterns in the data without providing any labeled information. Here the data are not labeled and we don't know anything about the data. The example is like learning without a teacher. Let's take an example of unsupervised learning. Let's say we give machine of 10 images of cat and 10 different images of dog, and the machine does not know how dog looks like and how cat looks like. But the machine will be able to cluster the 10 images of dog together and another 10 images of cats together. And the machine does this by finding the similarities between two different images and will be able to cluster together. So the process by which machine learns from the data without providing any labeled information is the unsupervised learning. And it's further subdivided into three categories based on how the model finds data pattern within the data. And these categories are: first one is clustering, and second one is association, and finally the recommendation system. While talking about clustering, the model clusters the different data into groups based on their similarity. For example, we can see the example of the cluster of fruits. We can see here the clusters of fruit. The computer algorithm clusters the given images of fruits into three groups on the basis of similarity of shape, size, and the color. We can see here this computer has clustered the given image into three groups, and it is done on the basis of like the color, its shape, and the size. And another one, like while talking about association finds out the relationship between two data points. For example, suppose we have a customer who has recently bought a house, and this this customer who recently bought a house is most likely to provide to purchase the furniture. So it finds out the relation between two different data points. And recommendation system, one of the most widely used unsupervised learning technique is the recommendation system. And These are the algorithms which are aimed at suggesting relevant items to the users, and the items may be like a movie to watch or text to read or product to buy or anything else depending on the industries. Like we can see here the recommendation example of the Amazon, where we can see the recommendation of book. Like suppose if I have recently bought a book and the customers like the system also recommends us the book, and we can see how it works, how the recommendation system for the book how the recommendation system recommends a book for the customer. And the the final one is the reinforcement learning, and this is a type of model which makes model to learn through the trial and error, and every time model moves or makes a right decision, it gets rewarded, and every time the model takes a wrong decision, it gets penalized. And the goal is to increase the reward and decrease the penalty. And it is also known as like learning with the critic, and it remembers the best option and build the data as it goes. Basically, the evaluation criteria consist of like rewards and penalties, and we give the input, and finally we get the output, which is the actions. And the learning is to increase the amount of reward and decrease the amount of penalty. And these are the these are the basics of machine learning types, and that and we in our subsequent videos we'll be discussing in more detail about the regression and classification.